Hello everyone and welcome to this section. In this section we're going to dig a little bit deeper into self-driving cars and try to kind of pose some requirements, okay, on an artificial eye that we want to put on a kind of a conventional vehicle that turn it into an autonomous vehicle, okay? And let's try to compare that to, our human vision system, okay? All right, so let's take a look. So our requirements, okay, if we are going to have, like a conventional vehicle and we want to turn it to an autonomous one, our requirements is we want our vehicle or that artificial eye that we're going to put, in place, that we want it to provide 360 degrees coverage around the vehicle, okay? We don't want, for example, the car to just have a vision system or an angle that, looks just in front of us, right? We actually want to, why not? Let's scan the entire range and make sure that we can actually make proper decisions based on the, the objects next to us on the right, next to us on the left, behind us and so on, all right? However, one of the limitations of humans as drivers is that we only see, in the front portion. Yes, obviously we can look in the mirror, but that's a different, that will distract us from looking at the front, right? So that's one of the main limitations. And as you can see here, the requirements that we want to put on our artificial eye is that it must provide 360 degrees coverage around the vehicle. However, for our human eye, we have our 3D vision for around 130 degrees of the field of view, which is, like this basically region that we can look into, around 130 degrees, all right? Some of the requirements that we want to put for our artificial eye, for example, in our self-driving car, that it must identify objects in 3D close and far from the vehicle, okay? Humans, we can actually look in the central region within 50 degrees, we'll call it, again, field of view, FOV, in high resolution. Outside that central zone, actually our perception drops. Behind or beyond that 50 degrees, our perception actually drops significantly. I can't see what's happening inside me here on the right or on the left, which is why, for example, we have when you go through like a driving exam, you actually have to check your blind spot because you have to change your angle just to view if there's a car next to you or a car coming, in the blind spot or not. Okay, and that's again one of the challenges. With self-driving cars, we can just put like sensors everywhere to actually scan the entire range for us, right? Okay, one of the major requirements as well that we want to put, for self-driving cars for our artificial eye, that we want to have all these requirements has to be met in lighting, in good lighting, bad lighting, in good weather, sunny weather, and during the snowstorm, for example. Okay. Actually, human eye is pretty good when it comes to this. We can actually adjust, to different lighting conditions, and it has kind of, in general, good performance in varying light conditions and in varying, for example, weathers and so on, all right? And obviously, we need to process data in real time. And again, humans in general, they are pretty good at that. Obviously, we can have, like a self-driving car that drives, or have like processing that's way faster than humans in general. I'm going to discuss that moving forward throughout the course, okay? All right. We, in general, have a very good kind of, like a frame rate in the central zone. However, poor in the peripheral vision, which is kind of, the side vision in a way, all right? Again, all of that, we are assuming that we have an amazing driver, excellent driver, who, like, for example, doesn't drink, or doesn't get distracted easily by cell phone or texting, and he's kind of young, so he doesn't have vision problems. He doesn't have, let's say, he doesn't want to go and have like lunch, for example, or hungry or whatever, and that's one of the main problems when it comes to kind of humans as drivers, that we are like subject to all these issues. So the assumptions above, we ignore age, we ignore disease, we ignore distractions, we ignore all this stuff, all right? Okay, perfect. So what's the conclusion? Conclusion is human eyes can provide a kind of acceptable vision in a very narrow field and a view just facing forward. What we wanted to do here is we wanted, throughout the course, is to develop kind of, like a computer vision algorithms and machine learning algorithms to actually start to detect and, kind of detect objects and become even better than humans, okay, as drivers. All right. So let's take a look at kind of, what sensors do we have in a self-driving car, all right? Obviously, we can put whatever sensor we want. The issues is cost, well, that's one of the major issues, and, like the capability as well of these sensors, all right? Okay, so let's take a look. Again, I'm not going to dig into a lot deeper within, the number of sensors that we can put and all that, just kind of general information. So as you guys can see here, first we can put, first of all, self-driving cars, we set of sensors to give us kind of a perception of the world, okay? When we as humans drive, we get kind of a perception of what's happening. Yes, around me, for example, I can see there's a laptop, there's, for example, a microphone, there's a camera in front of me. That's kind of a perception, and that's what I want to do as well for a self-driving car, okay? Okay, so in general, we do that perception, and we feed all this data for self-driving cars to a machine learning algorithm that can process the sensor's data and actually take actions. We want to, for example, press on the brakes, or let's say increase the throttle, or like turn left, turn right, whatever, take emergency actions and so on. All right. The first type of sensors that we use in general is the cameras. Okay, so camera can provide us with detailed images. Okay, it's just like your cell phone camera, and we can actually rely in this course on a lot of camera images. Okay, and then we use a machine learning algorithm, okay, that can detect, these, like, for example, features within the image, and can tell us, okay, that's, a traffic sign, that's like a stop traffic sign, that's a pedestrian crossing, and so on. So as you guys can see here we have, on the self-driving car, we have, let's say, video cameras. That's one of the major sensors that we put, okay? The next type of sensors that we use in general is what we call it LiDAR systems, which is light detection and ranging systems, okay? So LiDAR system mainly works as a radar. However, we use laser instead of radio waves, okay? These LiDAR signals or LiDAR sensors can actually help us kind of, develop kind of a 3D map of what's happening around us. They're very powerful, and that's why, kind of the rotating sensors that you guys can see when you see any self-driving car. And that's what we call it here, the LiDAR sensor, light detection and ranging sensor, okay? The only problem with LiDAR sensors or LiDAR signals is it's very expensive. All right. So camera are kind of cheaper. You can just, you can have it on your cell phone. You can have it anywhere in self-driving car. So cameras are very easy to basically cheaper in a way. But you need to develop a lot of machine learning algorithms behind it to actually, help us classify traffic signs and objects and so on. The next sensor that we use is the radar, which is, kind of pretty much similar to like LiDAR signals. However, we use radio waves to detect objects, and it's very cheap as well, okay, compared to LiDAR signals. Obviously, all of this, we need the vehicle to determine the location of it, because we used our maps, Google Maps, for example. We need to know precisely our location. So we use our GPS, or global positioning system, to provide information about your current location using, again, set of maps. All right. So as you can see here, we have our video cameras, we have our LiDAR, we have our radar signals, we have our processing unit, obviously, and we have, like a couple of rear camera too. We can put cameras anywhere if we want. And that's pretty much kind of an overview of the general sensors that we use in a self-driving car. All right. In most of this course, we're going to rely on the camera images to detect and classify objects, as we're going to see moving forward. So let's take a look at maybe a little bit more details about the sensors that we can use for self-driving car. That's actually a pretty interesting photo or image, of a kind of, self-driving car. As you guys can see here, we have our sensors 1 that can tell us, our GPS kind of signal that tells us, kind of our location or position, along with the map, so we can locate, can know what is our current position, and can predict as well our future position. The second step is we have our laser range finding, which is, kind of number 2, okay, which is number 2 sensor, which is kind of, like the rotating sensor or radar signal that can be used to build, kind of the 3D map of the world around us, can help us, like achieve perception. All right. That's the second sensor. So as you can see here, that's number 2 range. So that's the range of the number 2 sensor. Okay, it's just don't look in the front of you or the back of the car. We actually take a kind of, like a holistic overview of the image and the perception of the world around the entire 360 degrees around the vehicle. All right, the next sensor is the video camera. Okay, we specified the cameras are way cheaper. They're very cheap to put, you can just collect whatever images you want. And here, as you guys can see, it can identify, for example, road users, can identify lanes. As you guys can, actually, that's one of the projects we're going to be working on. We can specify, like the colors of the lane. We can detect, the kind of region of interest for our lane. And we can detect that all that by using camera images. We can even use it for traffic sign classification, and that's actually one of the projects as well we're going to be working on, which is how can we use the traffic sign classification along with a deep neural network that can classify traffic signs easily and effectively. All right. So these are kind of, like sensor number 3 per se. And number 4 for radars, they can be used to, again, locate it in the front, and we can put it in the rear as well to detect the proximity of obstacles. It can tell us, okay, what's the distance? How far are we from, for example, a pedestrian or from another car and so on. And that's pretty much, like all the sensors in a nutshell that we use for a self-driving car. And that's pretty much all what I have for today. I hope you guys enjoyed it, and see you in the next section.